Good morning everyone, welcome back to Question a Day. Today is July the 1st and we'll be answering the question from June the 30th. So this question is on quadratics and we'll get into it in a second. So today is World Reggae Day and June the 30th, if you're interested, is World Asteroid Day. So we've got this question here on quadratics. We've got 2x squared plus 16x minus 11 and we want to write it in the form of a times x plus b squared minus c. Now you might recognize this as completing the square. So the way we approach this question is, for part A, we're going to first divide through by this first term here. Well, not divide through, so to speak, we're going to factorize it out. So we'll take 2. We'll divide through by our expression. We get x squared plus 8x. So we've taken that factor of 2 out. And then it's up to you which you prefer. You can either leave this 11 outside of your bracket that you've made, or you can complete that multiplication and have 11 divided by 2. And then when you expand that bracket, it would become our original expression. So we're nearly there. We now need to get our x plus b all squared. And the way we do this is we're going to split this 8 term, so this 8x, in half. So we are going to get an x plus 4 squared. Now this is still in our square brackets, remember. And when we expand this out, we will get our x squared plus 8x. Unfortunately, we also get a 16. So if we were to expand x plus 4 out fully, we get x squared plus 8x plus 16. Now we don't want that 16 in our final answer, so we're going to subtract 16 there. Now we're still subtracting 11 from the end of this, so each of these phases is still equal to the last, but we're getting closer. So our next step is to expand this square bracket again. So we get 2 multiplied by x plus 4 squared. Now 16 times 2 is going to give us minus 32, and we can't forget that minus 11. Collect these all together, and this becomes 2x plus 4 squared minus 43. Now this is equivalent to our initial quadratic equation. So now it comes to part B. We want to sketch the graph showing all intersections with the axes and the minimum point. So for part B, we're going to take this expression, we're going to draw a set of coordinate axes like so. These do not have to be incredibly precise. We just need to do the job of being 2 straight lines that I can sketch a graph on. There we go. And we can use the information from this quadratic here to sketch this graph. First off, we know the y-intercept. So that's going to be this minus 11 here from the original equation. So when x is equal to 0, that's going to cancel out all the x terms. Our y is going to be minus 11. So pop a minus 11 here. Our next term, we need to think about potential roots that this might have. But we're going to look at the minimum point of this. And it looks like from this part here, now we can relate this to our transformations if we like. We could relate this to several other, so we could put some values in, we could see how it goes. We did learn a formula to kind of get this out as well, which is that the minimum point for this expression is equal to the inverse, so we flip the sign here for the x coordinates, we get minus 4, and we keep this one the same, we get minus 43. So it looks like we're going to get a point way down here with coordinates minus 4 and minus 43. Obviously this graph is not to scale. That's okay. It just matters that it shows all the relevant information. You can see it's not the most beautiful drawing in the world. It's a little bit kind of rubbish. It's not even very symmetrical, but it implies that symmetry in it. Okay, and we're going to indicate this point here as being -4 and -43. And if you wanted to, you could also find the roots for this equation. You could do that either using your calculator or by factorizing this. Now, I don't think there's a very nice factorization for this, just looking at it. So we'll turn to our calculator, where we will, if we pop this here, we're going to go to our equation mode. We'll put in a polynomial of degree 2, and you can see that's okay. We're going to put in 2, 16, and -11. And there it tells us, oh, look at that, that's a real nasty number, isn't it? -8 plus root 86 divided by 2. And then -8 minus root 86 over 2. It'll also confirm for us our minimum point. So we get a minimum of -4 and -43, which is what we got. Now, obviously, in the exam, we wouldn't be allowed to just use our calculator to tell us this. We would have to complete the square first. So we would need to have this information here in order to get the marks to show this minimum point. Now, if we wanted to indicate those roots on, we could. So that would be, let's see if I can remember this, -8 plus root 86 divided by 2, and -8 minus root 86 divided by 2. Again, the kind of salient points here are your y-intercept and your minimum. That's all for today, and I'll see you on July the 2nd.